Section 8.3, we are going to have three types of problems we might ask for: the total money flow, the present value of money flow, and the accumulated amount of money flow. Now for tests and quizzes, I will give you these formulas, so you do not need to have them memorized, you just need to know how to find them. And so for total money flow, it's the integral from 0 to t of whatever the function is times dt. For the present value, it's again that function f of t, but now times e to the power of negative r times t. R is the interest rate. And then accumulated money flow, we basically have that present value, but then we're also going to multiply by e to the power of r times capital T. So let's kind of build that up with our first example. Here I am just going to go ahead and give you this f of t is 75,000 times t. So our total money flow, here we want to find a 3-year period. So I'm going to integrate from 0 to 3 of my function, 75,000 t dt, and I just threw that in my calculator and got out 337,500. My present value, again, I'm integrating from 0 to t. There's my function f of t, but now I'm going to multiply it by e to the power of negative 0.08 t. Again, it's 8%, which I am given. And once again, I just threw that in my calculator. And then accumulated amount of money, you can see exactly what I used for present value, but then I'm also going to multiply by e to the power of that r times 3. And once again, I threw that in my calculator and got out about 366,200. All right, let's look at another problem, but now my function is not being given to me quite as explicitly as it was in the previous one. My previous problem, we were just told there's f of t, so that was pretty clear. Here, though, we are told that money is flowing continuously at a constant rate of 2,000. So since it's constant, that means it's not changing. So my f of t, or f of x, however you want to express it, is just 2,000. There's no variable there. And here we've got 5 years at 6%. So my total money flow is going to be that function 2,000, and I'm integrating from 0 to 5. And again, for all of these, I'm just using my calculator to do the actual computation. The present value, again, my rate of interest is 6%, so r is 0.06. I plug that in with my function, and I used my calculator. And again, accumulated amount of money, I've got that extra bit out front. But once I have that equation, I just throw that in my calculator, and I got about $11,662. Now, the last type of problem we're going to see is something that's going to involve exponential growth. So we are going to now need a third equation. Once again, do not need to have this formula memorized. I will give it to you. Y of t is y naught times e to the kt. That y naught is the initial amount, and the y of t is the amount after time t. So for this problem, we're told that the income is growing exponentially. So I'm told that phrase, growth exponential, so that's how I know I'm going to use this equation. And when it's first installed, it was producing at a rate of 500 per year. That is going to be my initial value. And then by the end of the first year, it produced an income at a rate of 510.10 per year. And we would like to find the total income produced by that in the first 3 years. So first of all, we've got to get a f of x or y of t, however you want to express it, equation. So my initial value is that 500, but here I was not actually told that k value. The k is the exponential growth factor, and generally for these we are not going to be told that. That means I have to find it. So we were told at the end of the first year we had 510.10. So that means my y of t value is 510.10 when t is 1. So I'm going to plug those in so that I can solve for that k value. So I divide it by 500, and then my answer is the natural log of that, which is approximately 0.019999869. It's a pretty small number. So again, we were not given that k value. I did have to find it, but I can now write my exponential growth equation is 500 times e to the power of that k value I just found times t. and I'm going to use that as my f of t when I find my total money flow. So again, our total money flow we want over the first 3 years, so I'm integrating from 0 to 3, and that y of t is this exponential growth that I did just fine. Nasty number, but that's what my calculator is for. So once I have that, I can throw it into my calculator, and I got about 2,600. So again, for all of these, you will be given all of these equations. We may not necessarily have to have the exponential growth on a test. There are homework problems on it though, so that is definitely going to be fair game for the test. And that is section 10.3.